This next section's on concentrations of solutions. So we have to figure out how strong of the solutions do we have. So when we're looking at sugar water or salt water, how much would we actually taste is a way we can measure this concentration. But now we're going to look at it mathematically. So when we look at concentrated versus dilute, so concentrated is something you taste a lot of. Dilute is something you wouldn't taste very much of. And so when we talk about solute and solvents, when we're talking about higher concentration, you have more solute. In lower concentrations, there's less solute, not as much. Concentration gives us a ratio. It gives us ways, there's several ways that we can show that concentration also. So the big thing here is percent weight volume. You've done this before in my class, either in chemistry or biology last year. So this isn't anything too new, and it's pretty easy to understand. All you need to do is take the grams of the solute, divide it by the milliliters of the solvent. So for example, in a diet drink, you have 0.035 grams. In 240 milliliters, you take 0.035 divided by 240, and you get this percent solution. That's all it is. So an example here, if you dissolve 12 grams of sugar in 150 mils of water, it's pretty easy to come up with a solution for this. 12 grams, 150 mils, it's 8% sugar water. We did this with the sodas earlier in the year, if you can remember doing that. So a lot of times we want to look at the mass, but a lot of times we want to look at the number of molecules also. And there's a way that we measure that. This is how I order chemicals, for example. It's called molarity, which is what we're going to get to. Before we get there, just a quick review of moles. So remember, 1 mole is equal to 6.02 times 10 to the 23rd molecules. That's going to come back. We're going to use that a little bit. Molecular mass in grams equals the 1 mole of that molecule. So for example, how many moles are in 25.5 grams of sodium chloride? Well, we take this formula. We have 1 sodium atom, 1 chlorine atom, and when we look at the periodic table, find their masses, we come up with 58.44 grams in 1 mole. Now, we don't have a full mole because we only have 25 grams. So we take 25, use our conversion factor here, divide it out, and we end up with 0.44 moles of sodium chloride. So this should be a little bit of a review for you. Now, what we look at and what we're most concerned about is molarity. And that's moles of solute per liters of solvent. So molarity, M, a lot of times represented with a large M, or sometimes it's M underlined. It's a concentration unit that uses moles instead of mass. And we use moles because we know how many molecules we have, which is really important for chemical means. Now, if we dissolve 12 grams of sodium chloride in 150 mils of water, what is the molarity? A couple key things you have to pay attention to here. We can use the same molecular mass. So we take 12 grams here, and we use our conversion factor to find out the number of moles. So remember, molarity, M equals moles over liters. And so here's our mole value right here that we can use to put in here. Now all we need to do is change milliliters to liters. So 150 milliliters gives us 0.150 liters. We can substitute that in to the bottom part of the equation. And a nice cleanly written one is down here at the bottom. And so our molarity value would be 1.4 moles of sodium chloride. Now, we're going to learn how to convert between the two. I'm going to stop right here for this example. This is all you need to know for tomorrow.